Today's computers virtualize the encoding process. A process that was practically impossible to be physically modeled can now be modeled on a computer. Processes that require great speed and scale of complexity. However, to understand the complexity of today's encryption and crypto in general, it's good to look at the past. Encryption, or secret writing, has been around for a long time. Let's take it back to the days of Caesar with the Caesar cipher, which is a form of substitution encryption. Here we can see the substitution method, which is simply taking the current character and shifting it back 3 letters. So a D becomes an A, an E becomes a B, and a C loops back around to Z. With the Caesar cipher, or substitution cipher, we can represent the complete plaintext per character and its associated ciphertext per character. This is exactly the same thing as a decoder ring. This is a specific type of substitution cipher we call a monoalphabetic cipher, meaning we're substituting one letter with one distinct other letter. If we wanted to take it to the next level with the substitution method, we could use a polyalphabetic cipher using multiple alphabetical substitution. But with our monoalphabetic Caesar cipher, Crypto Talk 6 p.m. at Xavier becomes the following. Here's another example of a cipher, which we'll call digital substitution. Here, hello is the plaintext, but represented by 1s and 0s, and David is a cipher, represented by 1s and 0s, which in turn creates the ciphertext below. Here are the rules for this cipher. 2 of the same bits equal 0, and 2 different bits equal 1. If you'd like to get a great book on the history of cryptology, I highly recommend The Code Book by Simon Singh. Encryption, at least from the literature, was primarily the realm of aristocrats and governments, but by the mid-20th century it became a huge business problem, and as business came to use encryption, more standardization was necessary. Some businesses had access to powerful encryption, but most didn't, and the interaction of these companies created the need for a strong encryption standard. In 1973, America's National Bureau of Standards requested submission of a standard, secure, business-to-business communication. In 1978, a product known as Lucifer became the Data Encryption Standard, or DES for short, created by Horst Feist, a German immigrant. This has a very interesting history. Reportedly, Feist was given a lot of trouble from the NSA, not for his German heritage, but because the NSA wanted a monopoly on cryptography. The NSA pushed him out of his research at the Air Force's Cambridge Research Center and then out of the MITRE Corporation, but finally he found some reprieve at the IBM Watson Laboratory in the early 1970s. Now, for this encryption process, the NSA worked with IBM to strengthen the encryption algorithm for all but brute force attacks. That is, a direct attack computing many keys in order to find the right one. From the NSA's perspective, they wanted all but the strongest governments to be able to break this encryption. That is, the NSA. They wanted the key size to be reduced from 64 to 48 bits, but it was eventually settled on 56 bits. Let's say for simplicity's sake that the DES is implemented using a key, function, and 16 rounds of scrambling. In 2001, the DES was replaced by AES, short for Advanced Encryption Standard, which uses substitution and permutation methods. A new standard was needed because DES was computationally intensive to encrypt a message, plus, in theory, it was possible to break encryption with faster than brute force methods, including linear and differential cryptanalysis.